in the last lesson, we were talking about horizontal asymptotes, and we had already talked about vertical asymptotes. So really, this page of notes is just a recap of stuff that we've already talked about. So we know that asymptotes are a line that a graph approaches but never touches. This is a little shaky when we talk about horizontal asymptotes. Like we said in the last lesson, with horizontal asymptotes, sometimes you do cross over that line temporarily, but then you care more about what's happening way out at the far ends, okay? So you're going to get to questions where it says, okay, just find all the asymptotes. And so we need to remember the difference between vertical and horizontal asymptotes. Vertical asymptotes you've been doing since Algebra 2. Vertical asymptotes come from non-removable singularities, okay? So this is where you look at when does the denominator equal 0. And then I would also recommend factoring to look for removable singularities. So in order to remove any singularities. And if nothing removes, then you have a non-removable, and that's your asymptote. Okay? Horizontal asymptotes are a totally different beast. Horizontal asymptotes come from, oh, I guess I was going to write this stuff down here. Sorry about that. Horizontal asymptotes come from these limits to infinity, and that was what we left off with in the last lesson when we were talking about that end behavior model where we're canceling things and saying, you know, we're only going to look at these terms in this function. Okay? So to find vertical asymptotes, we are going to set the denominator equal to 0 and solve. And then we are also going to check for anything that can be removed. Horizontal asymptotes, this is where we're going to use what's called the end behavior model. And that's what we were talking about at the end of the last lesson. That's essentially our way to find the limit as x goes to infinity of f of x. And if there is a limit, if this is a number, then my asymptote is at y equals that number. Now, if it's not at a number, if it's infinity or if it's that it doesn't exist, then you don't have any horizontal asymptotes. Okay? So, let's take a look here at example 4. Horizontal and vertical asymptotes. The vertical ones are probably the ones you feel most comfortable with. So for vertical asymptotes, what I want to look for is removability here. I know that I'm going to have a discontinuity at x equals 0, but the question is that removable? Well, technically, this is a little bit tricky. You have two x's down here, right? One of these x's cancels, but one is still there. So 0 is still going to be an asymptote on this graph. Okay, this is going to be a vertical asymptote for you because this is not removable. Let's talk horizontal asymptotes. Let's do that over here. Horizontal asymptotes, the question I really want to ask myself is what is the limit as x approaches infinity of f of x? Well, with an x on top and an x squared on bottom, this is where we're going to ask ourselves which is going to grow faster, the top or the bottom. The bottom would grow faster as an x squared, and so anytime the bottom of your fraction is growing faster, your fraction value is going to approach 0. So the answer to the question for the asymptote would be y equals 0. So make sure you're answering these correctly. Because, I mean, there's some work that you have to do to figure them out, but a vertical asymptote will always be x equals a number, a horizontal asymptote will always be y equals a number. Okay, so with the next one, for the vertical asymptotes, I would say, how do I make 2x cubed plus 8 equals 0? Well, I could probably factor, I can't really factor. I mean, nothing that's going to get me to cancel anything with x plus 3, but we'll check for removability here in a minute. I would get 2x cubed equals negative 8, which means x cubed equals negative 4, And so this would just be at the cube root of -4. We are allowed to take cube roots of negative numbers. We couldn't take a square root or a fourth root, but we can take odd roots. And since this is not like a root that I could plug in here and have this also equal 0, I know this isn't a whole. This is definitely an asymptote. Okay, so denominator equals 0. That's how I'm finding vertical asymptotes. Okay, horizontal asymptotes. I am asking myself, what is the limit as x approaches infinity of f of x? And again, I'm getting rid of all this stuff I don't care about, and I'm asking myself, what's growing faster, top or bottom? Well, an x cubed is going to grow faster than an x, no matter what you put in for x. And so this is, again, going to approach 0. That's going to be a really common answer. So you're going to have a horizontal asymptote at y equals 0. Okay, last one. For my vertical asymptote, I really want to make this denominator equal 0, right? So I want to say x squared plus 3x minus 10 equals 0. To solve that, I'm going to factor. So I'm going to say this is x plus 5 and x minus 2, which would tell me that -5 and +2 are my discontinuities. Those aren't guaranteed to be asymptotes. I would have to check to see if either of them is removable up here. Up to you what's easier for you. You could take the -5 and the 2 and just plug them in up top and see if that equals 0. I'm assuming that we're going to be doing this without a calculator. On your first quiz, you will be doing it without a calculator. So I'm going to factor this thing because I think it'll be more efficient, calculator free. I'm pulling an x out of everything. Okay, and then I'm going to say, well, how do I multiply to 12? I think I can do this with a 6 and a 2. So x plus 6 and x minus 2. Okay, so right here I see that I have an x minus 2 on the bottom and an x minus 2 on the top. So what that means is that this x minus 2 cancels, and so this is not a vertical asymptote. This thing here would be a whole. But for the answer to this question, I mean, I don't even have to write that. Like if you had figured that out earlier, I could have not written all of that. This is just your answer, right? Because this one didn't remove with anything. So that is your vertical asymptote. For your horizontal asymptote, we're saying limit as f of x approaches infinity. And in this case, up top, if I get rid of the stuff I don't care about, x cubed is growing faster than x squared. The top of your fraction is growing faster than the bottom of your fraction, which means your overall value is getting bigger forever. It's not approaching anything except it's getting larger and larger. This would be infinity, but that means that there is none. That was a bad grammatical sentence. I'm sorry about that. There are no horizontal asymptotes. Okay, so when your limit is infinity, what that's telling you is that there's no limiting factor. There's no asymptote there to find. Let's take a second and just verify these. Let's make sure that I'm not lying to you. X divided by x squared. Well, I should be seeing a vertical and a horizontal asymptote at x and y equals 0. That's what we said here. Okay. Well, that would mean the x and y axis. So I'm seeing that here as a vertical asymptote, and I'm seeing it here as a horizontal. As a horizontal asymptote. Okay, so that one checks. Next one was x plus 3 divided by 2x cubed plus 8. Okay, so I'm definitely seeing a horizontal asymptote at 0, right? It does this weird bumpy thing, but this is definitely approaching the x-axis on the left and the right, okay? I could zoom way out and see. I mean, it looks like it's touching the x-axis, but we know it's not. As far as my vertical asymptote goes, that's a little bit harder to see. But if I went here and said, I want x to equal, let's see if I remember how to do a cube root. I might just have to do a power. So I'm sure there's a way to do a cube root, but I don't want to waste your time trying to figure it out. So we'll do to the negative 1/3. And sure enough, that's the actual decimal value if you had figured that out. And then that's where your vertical asymptote is located. And then my last one was x cubed plus 4x squared minus 12x all divided by x squared plus 3x minus 10. Oh, what's going on? X squared plus 3x minus 10. There we go. Okay, so we said vertical asymptote at x equals negative 5. Let's see that. That looks about right. Okay, so where that green line is, you're seeing that vertical asymptote behavior, top and bottom. Okay, but I'm not seeing a horizontal asymptote, right? This thing is just growing and growing and growing forever. Now this is one that if we went to negative infinity, we would see that it's heading toward negative infinity, right? It's decreasing forever, but that doesn't change this answer, right? That doesn't change the fact that I don't have a horizontal asymptote. So I really don't care about the fact that it's, negative infinity or positive infinity. Overall, what I care about is that there's no horizontal asymptote.